Hey everybody, a student came to me and said that their extract words method works, but worked very slowly on large texts, such as the Count of Monte Cristo. So I want to kind of try and solve this myself in a fast way, just to feel confident that we can do it. So I thought I'd kind of live code it. So again, the idea of extract words is we have a large text, and we want to loop over the text and output an array list of individual words with all of the punctuation stripped out. So let's do this. I think first what I want to do is split on space, but I'm going to try and do this without using Java split method. So I'm going to write my own version of split on space. And then once we have that, let's loop over each word in words. And I want to clean it. And what I mean by clean it is I want to remove all punctuation characters from the start and the end of the word only. And then let's get another array list that's going to be clean words. And then I'm going to add that to the end of clean words. Oh, so actually there's really no sense in me. Here, I'm refactoring already. Okay, there we go. So the output from split on space can be the thing that I'm looping over. So then clean words dot add word, except I want to actually clean it. And then at the end, I'm going to return clean words. Okay, so the question is, okay, I forgot what I was saying. Somebody came to talk. But anyway, this is the structure of the code. So now I just have to implement these two methods. So let's start with split on space. I'm going to return an array list of string. And then text, great. So what I'm going to do here is I want to just make a single pass over this string. So I want to start at the beginning and loop over every letter exactly once. So here's the general idea. So I think a nice general approach is going to be we'll get one letter at a time, and as long as we don't see a white space character, as long as we're seeing letters only, let's add them one at a time to an outgoing word. So I'm going to have this kind of word string, and so I'm going to look at O, and it's a letter, so I'll add it, and then I'll see N, and it's a letter, so I'll add it, C is a letter, E is a letter, and then I find something that's white space. As soon as I find white space, I'm going to take that word and I'm going to add it to my array list of words. And then I'm going to start the process over. So now I see U, and I'll add that, P, O, N, and then I hit white space. And so we take that word and we add it to the end of the array list. So that's the general kind of concept that I want to execute now. So if we really want this to be fast, we'll need to use something called string builder. But let's actually not do that to start with. So I'm going to start at 0. I'm going to go to the end of the text. I'm going to use substring to get the letter out. So text.substring from I to I+1. And just to be clear, like, this is assuming that we can't use a lot of built-in Java methods that would just solve this problem instantly. This is more like a programming exercise to see if we can do it ourselves. Okay, so I'm looping over things. Let's make word be empty, and then I'll say if is letter, then word plus equals letter. Otherwise, if is white space letter, then I'm going to take my word and I'm going to add it to my outgoing array list, which I'll call words. So then I'll say words.add word. And then importantly, I need to reset my word to be the empty string so the whole process can start over again. And then at the end, I'll return words. Okay, so I've got to test if things are letters or white space. You've already written those methods, but I have not. So if letter.length doesn't equal 1, then I'll return false. Otherwise, I'll return, let me pause it. So here's isLetter. And then I'm going to do the same thing for isWhitespace. And there's definitely ways that this could be optimized as well. Like this is not going to run the fastest. But I think let's wait until we see it run too slowly, and then we'll optimize only when we need to. So here I'm going to count whitespace as space or tab or new line. Okay, so far so good. So now let's write clean. What I want to do with clean is I want to remove all non-letter characters from the beginning and the end. So I'm going to find first letter index, or no, sorry, I'm going to first letter index, and then last letter index, and then I'm going to return word.substring from first letter index to last letter index plus 1. So now I've got to write first letter and last letter index. So here I'm going to loop starting at 0. Oh, got to actually give it the word. All right. So we can say if word substring from I to I plus 1 is a letter, and we have isLetter for that. Then I'll return true. Nope, I'm going to return I because that's the index where we found the letter. If we never find a letter, I'll return -1 to indicate that we never found a letter. Find last letter is going to be just the same, except that we're going to start at the end. So word.length -1, and we're going to go all the way down until we hit 0. And same thing, if we see a letter, then we'll return the index. All right, so I think we finally got all the pieces. We wrote a lot of methods here, so, and we also didn't test any of them. So it might be worthwhile to run just a couple of test cases with individual methods here. If we wanted to, we could make a public static void main up at the top of TextLib just for the purposes of testing. So I could say, for example, clean. So let's clean this word. Hello. Now we can run it. Oh. Okay. Okay, I ran it, so I can see that it stripped away everything that's not the word hello, so that part seems to work. Let's test split on space now. So split on space. I'm going to say, hello, this is not my banana. And I included a lot of garbage characters in there just because I want to make sure that it's doing it right. Oh, so I forgot my split on space method. I don't actually want to have a bunch of empty things here. So I have a bunch of spaces in a row. So I'm glad I tested this separately. So if I hit a white space character before adding the word, I want to do this. I want to say, so if word.length is greater than 0, and word, well, maybe let's just do that. Okay, fair enough. Let's run it again. Okay, great. So we got hello, this is not my. So hello, this is not my. Oh, so it's missing banana. So why would it be missing banana? Because I don't end with white space. So I'm missing the last letter. So one thing that I could do actually would be this. Let's say text plus equals space. So now I'm guaranteed to end with a space. And so now I'll get the last letter. And now it says S banana because I accidentally typed an S. Okay, great. So the tests have worked. But this probably still won't be faster for the reason that I said, because here I am building up my string one letter at a time using plus. And if you remember, strings are immutable, which means that it's not actually modifying word. It's actually creating a new object every time. And that's very slow. So let's now fix that problem by replacing this with a string builder. And the string builder, what's the problem here? Okay. So now in the string builder, instead of trying to add a letter to the end of a string, what you do is you tell your string builder that you want to append a letter. You want to append a string to the end. And then I can ask my string builder what its length is. Whoops. And then when you want to actually turn your string builder into a string, you use toString. And then I'm going to... Okay, then I want to reset it. So I'm going to say, oops. So you could create a new string builder here, but I'm going to set length to 0. And that will like reset it for the next time. So now I don't need to do this. Oh, let's do it in the same spot though. Okay, so now I've rewritten it to use the string builder instead of actually adding strings one at a time. All right, so let's do a last test. I'm now reading in the Count of Monte Cristo, and then down here I'm going to extract words from file contents, which is not test sentence here, it's file contents up here. And that looks like it ran very fast, and it looks reasonably good. There's some things that I have questions about here. So like this one, hope you're, that seems like, so maybe it seems like there's some possibly minor bugs, although maybe not. We should look in the original text to see if it actually contains that letter, but at least it looks sort of at a cursory glance like it is working.